Hello, everyone. We are back. So this Ask Me Anything is actually kind of special because this is like a really like a full circle moment for me. So of course, everybody, you kind of know me. I'm Derek Johnson. I've been here more than a few times now, but today I had the honor of being joined by one of the pioneers of the whole TinyML movement. From the book, which was our motivation behind why we created the AI upskilling, and just everything that has to do with. I feel like he's like one of the ones that really kicked off the whole edge AI, the whole edge AI kind of avenue. So I'll let him introduce himself, and then we'll get right into this AMA.
Hey Derek, and it's an honor to be on here with you, and that's a much too kind introduction. I think I've just been very lucky to be around from when things were getting started, but I can't take credit for actually doing it. But my name's Daniel Situnayake. I work at Qualcomm too, but I work at Edge Impulse, which is part of our Qualcomm portfolio of companies, and my job is I lead the research team on Edge Impulse. So we're basically a developer platform for people who want to build edge AI applications. And my team's job is to figure out better ways of doing that. So like models that work on edge devices, techniques for training models for those types of use cases. Before that, I was working at Google and helped launch the TinyML book, which I was a co-author of, and also TensorFlow Lite for microcontrollers, which this book was kind of an introduction around. And it was really an amazing privilege to be part of that, because it was the first time we had this like mass sort of developer capability of building machine learning models or deep learning models specifically that run on embedded devices. So before that, it was something that was possible and had been done by like big, highly resourced companies like Google, like all the smartphone manufacturers as well. But after the TinyML book came out, and after TensorFlow Lite for microcontrollers, this was something that anyone could pick up and play with and start building. And then all the work that we did at Edge Impulse was sort of building on top of that momentum that came out of the community that evolved around this. I remember when we started, we had these little tiny meetups with a few dozen people. And now there's this whole worldwide movement of people that are in big companies working on embedded machine learning stuff. So it's been a really cool journey to see that happen.
Yeah, that's awesome. And it's interesting because the TensorFlow Lite for microcontrollers is still the de facto way of running models on microcontrollers. So, so that's interesting. So you started with Google, and then somehow you made your way to Qualcomm. And now, a little bit about my background is, so that it's not just me saying this is full circle. So at my last company, I was actually in corporate R&D, and this is when, AI was still, a lot of people weren't really believers, but we had a bunch of statisticians that was like, okay, we need to do something. So me and a colleague of mine, we pioneered a way for, the engineers in that group to quickly upload data and do it was just simple stuff, linear regressions, random forests, Gaussian, stuff like that. But when I read the TinyML book back then, that's when I kind of knew that I wanted to, focus in and cue in on, TinyML. And this was back when TensorFlow and Keras was running everything. They weren't even together at the time. And then I came to Qualcomm, and they actually offered a course on TinyML. So I took the Coursera course. I think they still owe me some money for that, but, because I missed the deadline. But, that's another story. But yeah, so then that's when I got the certificate, and it's just pretty interesting, how now we're here, kind of working at the same company. And somebody was like, "Well, Daniel works here," and I was like, "What?" And I was like, "That's when I had to, ping you and get you involved in this, because that book was the inspiration behind this first course that we dropped." So I guess, what was the motivation behind the TinyML book?
So I think it was It's kind of interesting. So Pete Warden was like the guy behind the TensorFlow Lite for microcontrollers effort, and so he'd founded TensorFlow Lite at Google a few years prior, which was basically Google's sort of attempt to build like a easy to use tooling for running deep learning models on mobile phones, and all sorts of things people are doing, like face recognition and filters for Snapchat and stuff like that. But there needs to be a way to have models work in this repeatable form so that mobile developers didn't have to like implement this super crazy stuff every time they wanted to integrate a model into an application. And then Pete realized the same thing was true for embedded hardware more broadly, but the original TensorFlow Lite was too big, too hefty to run on a microcontroller. There's at the time we're looking at like mid-range, like MCUs, like Cortex M4 kind of thing. You've got like kilobytes of memory. Not the type of thing that we're looking at today. So you really couldn't deploy the full big beast of TensorFlow on there. So TensorFlow Lite was designed as the TensorFlow Lite Micro was designed as this lightweight framework that just had the bare essentials basically. But then we worked with a bunch of different companies that built silicon to make sure that the optimizations were available for all these different microcontroller architectures and accelerators. And so the reason we wrote the book is because that's all good and fun. We've got this technology that can do this cool stuff, like including computer vision, or we had like examples of gesture recognition and audio keyword spotting, that type of thing. But the idea that you could actually do this on a microcontroller was so new that no one even knew about it. Even on the cell phone like platforms are like way more capable. Still, people didn't realize that you could run deep learning models on these things. No one knew what deep learning models were, barely. I think so many developers now, especially since this big AI boom, we've all got this general understanding of like what kind of math is involved with running a deep learning model. And back then, this was like 6-7 years ago, I think it was a lot less clear for a lot of people. And so let alone thinking about the use cases and applications and that type of thing. And there was really an incredibly steep learning curve. So what we tried to do with the TinyML book was basically come up with the step-by-step guide to understanding exactly what is this stuff, what's it capable of, how does it work, and how can you integrate it into your embedded software.
Yeah, that's awesome. And actually it's interesting because Qualcomm, our NPU, we support many runtimes now, whether it's Onyx runtime, whether it's LiteRT, whether it's Executorch, but historically the de facto way to get to our NPU was using our TF Lite delegate. Now, of course, we weren't going as tiny as the MCU layer because we do, NPUs, but that's just the history of TF Lite. And it sounds like you were involved or you were a part of the group that kind of pioneered that, which is freaking awesome, kind of, to say the least.
I mean, I feel very lucky. It was just pure luck. I was looking for something interesting to do with machine learning and low-level engineering, and just found this team at Google. And Pete asked me if I wanted to co-author the book, and so yeah, it's the goal was to kind of make this guide that teaches you everything you know to get started. And the problem is it ended up being about this thick, because there's a lot you need to know to get started, and that was just to get started. This stuff is very complicated. There weren't any tools around at the time that help you with collecting a data set, training models, that type of thing. It was all stuff you had to do very manually yourself, like writing the scripts, writing the embedded software, gluing it all together. And then things like quantization, where you're reducing the precision of the weights in the model and the activations during runtime. That was so like unknown. I feel like everyone's heard of quantization now because of LLMs being quantized. But back when I joined that team, that was like a learning experience for me. Like, wow, this is actually something that works. I can't believe it's actually possible to just throw away information from the model and it still works okay.
Yeah, it's and with quantization, that's one of the big things with these LLMs and getting them small, and now we're really pushing the edge. I saw 1-bit quantization working on one of our Dragon Wing devices, and I was like, oh, this actually really works, so it's kind of crazy how much we're pushing, and we're pushing the quantization schemes. So what are some misconceptions that people have about TinyML?
Yeah, okay, let me think. So I'd say the number one thing that's been like just an issue the whole time is like what can you do on edge devices? And at the beginning, the whole reason we call this TinyML, when we like wrote the book and when we started like building a community around it, was that it was tiny little models compared to the standard ones at the time. So the big thing, back then was convolutional neural networks for computer vision had just got to the point where they're really, really effective. You could like download a pre-trained object detection model, pre-trained on a bunch of household objects, and it worked pretty reliably. And so people were using these types of things in applications on phones and stuff like that. But those were kind of too big to run on this tiny hardware. So running stuff on microcontrollers, we're really talking about models that were like a couple 100K max, nothing bigger than that. And so way smaller than what you can run on a cell phone. And the thing is, hardware, time hasn't stood still, and two things have changed. One of them is that the hardware on the edge has got way more capable, and then the other thing is that the algorithms have got more efficient too, and we figured out ways of training smaller models that do equivalent things. So where before you could do like maybe one frame every few seconds of inference on a image classification convolutional model, now on the equivalent low cost, low power hardware, you can get multiple frames per second for computer vision. And then we've got tons and tons of hardware that can run really quite big models. So TinyML stopped being tiny, a few years back. And now we've got models that are tens of megabytes or hundreds of megabytes or even gigabytes in size running on edge devices doing useful work. And it turns out, I think for me, the stuff that's important, the thing that unites all of this is not the smallness of the models. It's the fact that it's running on the edge. And so this new term kind of came out, edge AI, which refers to doing any kind of AI on the edge. And there's also the transition of using the term ML, where we used to be kind of ashamed to say the words artificial intelligence out loud because there was this big AI winter that had happened, the last big giant boom in AI, which resulted in very little useful stuff. But then we had this like data science era and like big data era in the tech industry that got people thinking about machine learning more. And then all of a sudden it started being possible to train big, deep neural networks because of some advances there. And so we've like got all this technology under the ML banner, and then suddenly, as soon as this like language stuff with transformers took off, people started being comfortable saying the words AI again. That's kind of got retroactively applied to all the rest. So we refer to things as AI now, which we were calling ML 10 years ago, 5 years ago. So that whole terminology has changed. And now we're not caring about whether it's tiny or not. We just care about, is it on the edge? And we don't just think about machine learning and like little classical ML models, decision trees and stuff like that. is a term that's including everything up to the biggest, fanciest large language models.
Yeah, I remember putting slides together to try to explain, at my last company, and it was like I didn't really. A lot of people didn't realize that, machine learning is everything. Deep learning, and ultimately, what we're looking at now is really a subset of, of the whole machine learning paradigm. But there's a couple of things that you just said that, I'm actually relieved that you said it, because when I was first developing this course, I was like, the TinyML purists are going to not like this course at all, because it does. I mean, we have the Arduino Uno Q that has this dual brain. We have the MCU and the NPU, and a lot of that course, which is using the Arduino App Lab and Edge Impulse, is running the models on the NPU, not on the MCU. And I'm like, the purists are gonna probably hate this, because TinyML was models running on the MCU. But there's another thing that I also wanted to tap on, because I don't know if a lot of people, I didn't realize it at first, but so we had the TinyML foundation, but that same foundation is now called the Edge AI Foundation. Can you talk? I mean, you already did in what you just said, but can you just highlight the reason for that transition to Edge AI Foundation that we know it as today?
Yeah, it's the same reason. I mean, when we were starting with the TinyML Foundation, it was really just like a few companies coming together in Silicon Valley. Like, I lived there at the time, and we had the first TinyML summit was in a meeting room on the Google campus. It was just like a fairly small room with a bunch of people with cool demos. And then we started doing all this like online content and online stuff, especially through COVID times. And it turned into this big thing. But like, as the community got bigger, so did the breadth of like what was possible with the technology, and the hardware got more capable. And as companies that design silicon started to realize that these deep learning workloads were relevant on the edge, chips started being designed that could actually run pretty sophisticated, big, chunky deep learning models on edge devices. And so it stopped being tiny and started being broad. So we started just referring to the edge part. So the Edge AI Foundation, which is what it is now. And I think for me, the thing that unites all of this stuff is the benefits to doing AI on device are universal, whether you're talking about tiny devices or bigger, relatively more powerful devices. There's this really nice acronym, BLERP, BLERP, and it stands for bandwidth, latency, economics, reliability, and privacy. And those give you basically the kind of justification for why you would run something on device. So privacy, for example, if you don't want to be sending data to the cloud because you have an industrial facility with proprietary techniques that you use, and you don't want to be shooting all your data off to a big cloud company and not know whether it's secure. You've got like bandwidth, like maybe you're in the field somewhere, you don't have a good network connection, you can't send entire images up to the internet, so you need to do some analysis on the device first. All of these things cover the gamut of like TinyML all the way up to like big edge devices. Even a self-driving car is edge AI, really.
Yeah.
And it doesn't really make sense to just draw a line arbitrarily based on the capabilities. The line should come with, does it have these characteristics that let it fit into this kind of bucket? And then as an engineer, you can choose things from that bucket that are relevant for your use case.
Yeah, I think this is just my opinion, I may be the only one, but I think, the future, there will be this symbiotic relationship between the AI, the cloud and the edge. It has to be, and of course the powers that be will have you thinking that we need 1 million data centers, we need this. But I think what it really will look like is that there will be some kind of understanding of what can be done on the edge and then what needs to go up to, you know, based on whether it's the ambiguity of the prompt, you know, and I'm talking more in terms of generative AI because it's going to keep getting expensive, but it doesn't all have to run on the, you know, on the cloud. I shouldn't have to I shouldn't need to be on the Wi-Fi to ask my, you know, whatever my home device is, what time it is. You know, exactly, that's something that a model, yeah. So I think there's going to be this symbiotic relationship, and things are going to land there with edge AI and the cloud.
Well, this is almost like what got me excited about this field in the first place is it's almost like a resistance movement against this assumption that everything has to go to the cloud. Like, there's obviously a lot of vested interests out there in like making it seem like you have to do everything in a data center, whether it's just people's business model depending on it. You know, you've got like companies that are charging subscriptions for features for products, whereas if you can just do that on the device, there's not really a way to justify it. Yeah. It's very exciting to me to think that you can move so much of this down to the edge, and it doesn't have to break contact with the cloud. And if there's stuff that works better in the cloud, do that stuff there. And even on devices, you've got this like heterogeneous compute concept. So like with these Arduino boards, you've got 2 cores, and so you can run some compute on one, you can run some compute on the other, divvy it up by task. And it's very common to have, we call it a cascade of models, where you've got one model that's like a kind of gating function. It's like you use a little bit of energy to run that very quickly. If it looks like the input justifies going up to the next level, then you do that, but you don't run the big powerful model every single time because you'd be burning so much energy. So this, to me, this technology is all about like breaking that assumption that you have to always do things with the biggest, most powerful hardware or system that you have at your disposal.
Exactly. Okay, so we have a question from Discord, and he or she is asking, as a beginner, what is the biggest knowledge gap you usually see when people from infrastructure backgrounds, so he's a network engineer, move into AI, and how can I bridge that gap early on?
Yeah, that's a really good question. Funnily enough, I have a degree in computer networking. I was doing my like CCNA and stuff like that at the start of my career. I've kind of just jumped from thing to thing, and I think with AI, it's such a broad field now that we have to get specific when we're talking about AI. Are we talking about building applications using large language models, or are we talking about low-level stuff, actually creating models like neural network architectures to solve particular problems? And so there's a whole world in there of that stuff. I think the first thing would be to like figure out what part of that interests you the most. Like there's kind of two axes there. Like one of them is like the application engineering at one end, where you're building applications using the technology. So like maybe you're like taking a model someone else trained, giving it some input, doing something cool with it, taking the output and actually like using that in an application. And at the other end is like the actual modeling and using the very low level machine learning tools to kind of create these models and train them and have them do stuff. There's also this axis of like low level programming to high level programming. So are you doing like optimization of kernels to make the computations run really, really fast? Or are you more concerned with like the training and that side of things and like making the model be accurate? And so depending on what interests you as an engineer, it's like a whole microcosm of the rest of engineering. Like you can work in AI and your job is like networking. You know, if there's a ton of networking jobs in like training these big models, it's all about networking, like bandwidth information flowing through these big data centers. But then at the low level, it could be like jumping around in a debugger trying to get the most performance out of some C++. So I would just say, look at all the different pieces and figure out what resonates with you the most, because you can't do it all. There's so much that I don't know about. Like if you think of the whole world of machine learning and AI, like I know this tiny little corner, and that's where I've just got to be happy, because no one's brain is big enough to fit all of it. Maybe if you're bored.
Yeah, no, I was gonna say, and I think that's spot on, but it's like with anything, because even with like, electrical engineering, you have electromagnets, you have signals and systems, you have circuits, you have device physics, you have all of, and you can't know everything. So you have to kind of, like exactly what you said, choose what interests you, or maybe choose where you think the future is going to go and drive in that. And then eventually you start learning how to filter out the noise, because there's a lot of noise out there also. So it's just, but yeah, pick a lane and just stay in that lane, and then you'll start seeing how you can, a lot of things overlap also. So, but yeah, getting started, it can be daunting if you don't, like you basically said, choose something that interests you and just go deep down that path.
And there's a good opportunity there for a plug for another book that I co-wrote, which is this was like a few years after TinyML, and the idea is that it's a big overview of the whole field of edge AI, and it has just like a briefing on all the different parts. So it's designed to be pretty high level. You can just flip through and like learn about like what kind of hardware are important, what kind of algorithms, what are the different jobs that exist in projects that are when you're building edge AI stuff. And we have a link you can go to where you can sign up and get the PDF for free. So we can share that in the video.
They dropped that in the YouTube chat already. Awesome. Man, everybody beat me to the punch, because I was going to ask you, if you were going to rewrite a book today, what would you do? And then, but there it is. There's the rewrite.
Well, funnily enough, we've actually just started. Today we had the kickoff meeting for the second edition of this book. And so it's just going to be AI at the Edge second edition. But since we wrote this a couple of years ago, we basically, this whole field of LLMs and generative AI has jumped into the mainstream and also jumped into the edge. So this book doesn't cover that side of things, but the new edition will. And it's crazy that this whole new field has just appeared, in the time since we wrote the last edition. And it's going to be the big part of this field going forward.
And so for that book, the one that you just wrote, is that you and Jenny? Jenny's awesome also. I've been in meetings with Jenny.
Yeah, Jenny's amazing.
Yeah. So is that going to be, I guess, for training? Are we utilizing Edge Impulse? And okay, perfect, because that is the perfect way, like to this guy's question, that's the perfect way to get started. And then from there, you can go down you can understand where you kind of want to land, and then you can go down whatever rabbit hole you choose to go down. So that's awesome. Yep. And there's
I think it's always most fun to get started by like building something and then looking at like what part of this do I feel drawn to and I want to dig into deeper. I don't have any formal background in AI or machine learning or really even software engineering. I just sort of followed my curiosity and looked for opportunities to. I think for me, it's like if you have the opportunity to work at something during your day job, then you just get so much experience, and you're always looking out for these things where, like, right now I'm kind of curious about robotics. I don't know a lot about robotics, but I'm trying to look out for ways to work with some of our robotics teams at Qualcomm that are doing all this amazing stuff, and just trying to absorb some of that knowledge and maybe get the chance to help out with some things. And that's how you find what you like.
Yeah. Stay curious, keep learning, especially in the age of AI, because it's a constant move. In my mind, this is like AI moves in dog years. So even though the original TinyML isn't old, in AI terms, 1 year is like 7 years. So, so because things move so fast, just stay curious and keep learning is, how you can eventually get up to speed. And then next thing you know, you're going to be where Daniel is. So
still not knowing anything, but at least I'm trying my best.
yeah. So then, okay, so we have another question from YouTube. Are there any recent AI trends that worry you with respect to edge deployment?
Yeah, I mean, this is a subject I'm pretty passionate about, really, the idea of ethical AI and effective AI, because as engineers, we are used to having a certain set of constraints and limitations and categories of bugs that we encounter and mistakes we can make when building systems and software. And AI really is just like a new way to build software, whether it's by supervised learning, training models using data sets, or whether it's through zero-shot stuff like prompt engineering, where you tell the LLM what it's supposed to be doing. And it brings a whole load of new mistakes that you can make when you're building a product or a service or trying to solve a problem. So all of these gut feelings we have when we're working as engineers, and like, oh, this is a risky thing to do, we might have a bug there, we need to be extra careful. All of these sort of gut feelings and best practices need to be figured out for building things with AI and machine learning. And part of that is even asking the question, is this something appropriate to do? Is it possible to do this effectively and ethically using AI and machine learning? And there's a whole load of use cases where the answer is actually just no, it isn't possible to do this effectively or ethically. So one of those that I could mention there is like weapons. Like, so you're making weapons which target people using AI, and no matter whether you're the good guys or the bad guys,
Everybody thinks they're the good guy.
Yeah, it's everyone always thinks they're the good guys. It isn't possible to say with 100% confidence that your computer vision model is going to shoot the right person or do the right thing. We just can't say that. It's a limitation of the technology. And so that's something that as engineers, we need to steer clear of. Qualcomm, for example, has a responsible AI license, which governs all of the AI stuff that we do, that expressly excludes all of that type of application, because it just isn't a responsible and effective use of the technology. So I think there should always be this filter that you use when you're looking at what kind of use cases and applications to work on. And it doesn't have to come from a sort of deeply moral and ethical view. It's not like we're going to consult with a philosopher and a priest to figure this out. Sometimes it's very clear just from an engineering point of view. If you just put your engineering hat on and say, can I stand behind the effectiveness of this? How can I measure whether this is going to do a good job when it's deployed? How can I know when I sign off on this and it gets put in a product that it's going to actually be effective? And if the answer there is, I have no way of knowing until it's out there in the product, that probably isn't something you should build. And so that's a big pitfall that people have to be careful not to get into, because I think it's quite new. We're still working out the best ways of measuring this kind of effectiveness. And it's a new world for us to figure out best practices in.
So would you say, listening to you, would you say it's one of the main problems is that a lot of especially with generative models, it's probabilistic, and not deterministic enough to have that kind of impact. Is that a good way of saying that?
Yeah, exactly. And it's all sorts of all the capabilities that these models have are sort of inherited from the data sets that they're trained on. And we know the data sets have these blind spots, and we call it bias in the field. That's a technical term. It's not like a political term. It's just the idea that these data sets, they're supposed to be a sample of things in the world. So imagine we're making like a keyword spotting model that's going to detect what word we're saying. So it's going to detect whether we say like hello to like wake up an appliance or something like that. So our data set needs to have coverage of as many different accents and types of voices as we can find. So it could be adult's voice, it could be my English accent, it could be an American accent, a French accent, all saying these words. Okay, you think you've got all these things, you've spent loads of money collecting all this data, and then you train the model and you find out, wait a minute, we didn't get any kids' voices. It doesn't work on kids. And unintentionally, we've got this model which just doesn't serve like a huge chunk of the population because the designers didn't think about it when collecting the data set. And so that's true on the simple models, like a keyword spotting model. If you think about like a big LLM, like a generative AI model, its data set is where all of its knowledge and understanding comes from. And so if the data set has weak points, like our little data set was missing children's voices, if the data set with all this information has less information about certain topics, the model's not going to be as good when it's working in that area. But it's incredibly hard to know that ahead of time. You have to do a huge amount of testing and probing to try and map out the way that that's working. So one of the things that's cool about these models is that you can ostensibly write like a prompt, and then the model knows what to do and can do something. So you could write a model that's like a prompt saying, tell me when there's a dangerous situation. And then the model will use its innate knowledge to tell you when there's a dangerous situation. But if you're deploying that in a factory and the training data for the model doesn't have any information about the kinds of dangers that are in your kind of factory, that model's not going to be effective. So you have to test it all beforehand. And that's really hard.
Yeah, and then the problem also is that the model doesn't inherently understand when it's weak on a subject. So that's when hallucinations start coming in, because it doesn't really know what, I guess people do that. Some people do that also. You know, we may not know what we're talking about and we're still just, you know, trying to
all the time.
instead of just saying, I don't know. So maybe that's why models do it. But I know we're running on close on time. Let me get to a few questions. So Kevin asks, what skills do you see? Okay. What skills do you see missing most often in engineers trying to move from cloud ML into the edge AI? Ooh, I have a good answer for that.
Oh yeah, good question. I'm curious to hear what your answer is. Mine would be a quick one. Is just sort of understanding how embedded devices work and how does an embedded engineer think, and what are some of the challenges in the embedded world, because it's very, very different. We have it easy up in the cloud, sort of standardized computing, like general purpose computer world. When it comes down to embedded hardware, there's so much variety and capabilities of devices and the tooling that you have to use and all of this type of stuff. So it's like instead of everything just kind of being the same and you can just containerize everything and not really think about it, you're constantly running into like features of the silicon that you don't have to really think about that when you're working higher level. So that would be the big one for me.
Yeah. And for me, it's just, you know, essentially what you said, you know, constraining. We have to really constrain the problem. And that forces you to get creative with how to, because in the cloud, it's like, hey, we got 2 trillion parameter model, 40 trillion parameter model. Let's just throw more GPUs at it. But when you come to the edge, you have to think about, okay, am I compute bound? Am I memory bound? If I'm memory bound, what are tips and tricks I can do to make that movement faster? If I'm compute bound, we can typically, I mean, our hardware is pretty good with compute bound isn't really the issue, but just really constraining the problem. Okay, I have a 7 billion parameter model. I'm going to quantize. When I quantize, now I may lose some accuracy. So now I need to fine tune it or find different quantization techniques. So there's just a lot more that you have to think about and you have to take care of, take note of when you're deploying on the edge. But that's the fun part also, because a lot of people don't really focus on the edge. So we're kind of like, especially Qualcomm and Edge Impulse and even Google, kind of are pioneering a lot of these techniques, whether it's, you know, group query attention or, you know, speculative decoding or any of these different techniques that we use to make these models run on the edge. Okay, so Rain asks, do we have any, or do you know of any resources for learning more about AI ethics? I think there's a book called AI Ethics.
Yeah, I don't remember off the top of my head, but there's a ton of stuff out there. We have a bunch of stuff in the AI at the Edge book that's around effective AI. So how do you, through the workflow that you're going through as you build a product, you need to integrate this ethical thinking throughout it. It can't just be something you do at the end. So we have a bunch in there, and I think there's some links for more resources. But I would just do some Googling. There's some really good papers about this type of stuff as well. So don't feel like you're just constrained to like normal published books. There's loads of good academic literature, and there's some quite good resources out there online.
All right, and we'll take one more question before we wrap this up. Does Qualcomm or Edge Impulse provide farms of hardware and agent-to-agent configurations? Testing real devices, inference, and getting logs would be very useful. Totally agree on the ethical side. Hippocratic License 3.0 is also a good alternative. So I know Qualcomm does have QDC, which is our Qualcomm Development Cloud, where you can go and actually test on real devices. Also, AI Hub, they allow you to, when you fine tune a model or when you compile a model, they allow you to push to your targeted device to get some performance metrics. Regarding agent to agent, I'm not sure. And then Daniel, of course, can speak to Edge Impulse.
Yeah, for Edge Impulse, we have some tools for doing performance estimation, but that's generally for smaller models, not for generative AI. Other than that, yeah, I'm not sure.
Well, so Edge Impulse has the same things we have also, because we're all, you know, one big family now. But anyway, Daniel, thank you for joining this. And, you know, and if you haven't had a chance to take the AI upskilling, it's mainly focused on Edge Impulse. So it should complement the book that the AI at the Edge book that Daniel wrote, Daniel and Jenny. And also, yeah, just thank you for all you've done to pioneer, to help, you know, usher in this AI at the Edge. And thanks everyone for joining, for all of your questions, and we'll see you next time.
Yeah, thanks so much, everybody. And yeah, looking forward to chatting again soon.
All right, bye-bye.
Bye-bye.